The basis of this paper is to explain the effects of urban heating island on the warming of urban areas faster than its surroundings. For example, Fujibi in Japan has about 2 degrees Celsius per 100 years more warming than the rest of Japan. Some of the causes of urban heat islands are absorption of sun, absence of plant transpiration, and differences in air circulation in the rural areas. The picture shown here is a graphic representation of urban heat island. This shows the sunlight being brought into the city and being trapped because of the differences in the surroundings. This graphic is comparing the differences between a natural landscape and a city. The warm air is brought onto shore, and then the cooler air is brought offshore using a breeze in the natural landscape. In the city, the heat is trapped in the city because there's very little breeze that can bring the cooler air offshore. Urban areas are overrepresented in the siting of temperature stations. Less than 1% of the globe is actually urban, but 27% of the stations are actually in cities. So the question arises, is the presence of urban stations results in overestimates of warming of the global land average? The approach to this experiment was as follows. 2 averages were constructed. One average was based on stations that were very rural, and one average was using all stations' data. The difference between the 2 sets were evaluated by the data set including all stations is an over-representation of warming. The data set with no urban heat zones would be underestimating warming, and if the difference were large, then the data would prove an urban heat island effect.
Now we'll discuss the requirements and selection of data for the study. First, the data must be free of seasonal distortion, and the use of raw data is critical to gaining a true picture of climate change. Data with pre-processing requires a bias in other studies, such as the HAD RCU and NOAA global warming studies. Next, we'll discuss the rationale used for selecting the data. The Berkeley Earth Surface Temperature Study stations were chosen due to quantity and coverage, while the MODIS 500-meter global urban classification map was chosen due to its accuracy in locating urban features. The MODIS Urban Extent Map is constructed from satellite data by supervised classification methods. It isolates urban areas dominated by a built environment from socio-economic factors. It's more accurate than previous maps constructed from nighttime lighting and outperforms other global urban maps due to the high resolutions from the half-kilometer pixel. Here is a rendering of the urban extent map using the same dataset used to classify stations in the Berkeley UHI study. While the data looks sparse, it's highly detailed in closer renderings. The Berkeley Earth Surface Temperature Study data comes from 15 existing data archives. The data is recorded monthly and comprises of 36,869 stations. It is filtered and merged with a multitude of different filters for accuracy. Learn more at Berkeley Earth's website. Here is a rendering showing coverage of the very rural stations used in the study. Although the data was highly detailed, there were several issues related to the correction of the stations. The MODIS urban extent map is more accurate than some of the station data. About 1/8 of stations are located to the nearest tenth of a degree, and some of the station data has gaps and reutilized names. The researchers applied an algorithm to correct for a lot of these errors. However, only 18% of sites were classified as very rural. The research decided on several assumptions in the use of the data. All areas classified as very rural were considered to have never been urban, while not very rural sites were not assumed to always have been urban and may consist of sites that were rural historically and have gradually become more urban, and sites that have become more urbanized over the life of the monitoring. The above assumptions is why the team decided to not try to identify urban areas, but to instead focus on the more rural areas and use the very rural stations as control.
The Berkeley Earth Surface Temperature Global Average method is used for more to obtain a more rigorous estimate. Basically, it is a complete global land temperature record reconstruction of such. Prior to averaging, a few steps that must be taken. That include the station records are broken using metadata at times of changes in observation, gaps in record, and the location of the particular station. Broken at times exhibit changes in the statistical properties by comparing them to other station locations, which is to say, if some are, they're greatly different than others, they're reduced in most matters. To continue the process, when the averaging starts, the averaging process stations are weighed according to their reliability and spatial correlation. Now, that's also to include the dates when they were established. For uncertainties, the average is calculated that incorporates statistical and spatial incompleteness uncertainties. Um, there are some stations that have been around for a very long time where they have to be updated, where more modern ones are actually more reliable. The effect of very rural stations are evaluated by applying the Berkeley Earth's surface temperature averaging procedure, and this goes back to saying where if some are more reliable, the data is more reliable. With not, if some are greatly off, I would say those can be reduced and they can be tweaked as what it is expected of them. And then finally, by comparing the resulting averages, the impact can be quantified by site selection not subject to urbanization temperatures. Just saying that there are some stations that are more valuable for the most part, and they'll provide a better average. Along the way of the Berkeley Earth Surface Temperature Global Average, the segregation of station procedures is a trend in socioeconomic factors that are compared with trends in temperature. The, so just to say how if some temperatures are off or some data is off, it also can always be reduced. And specifically, this is segregated. So two approaches are taken. The segregated approach is justified by using a measure for urbanity that shows no change in socioeconomic factors. And furthermore, some stations have never had a socioeconomic activity and therefore are interpreted as having no trend, which means they do not contribute too much to the average data. Um, Such stations are just ones that are never don't see much change in climate or temperature that are almost insignificant. And while obtaining data, and sometimes for some stations this is expected. There is an expected data that is collected during the full averaging procedure, but in some cases, some of the sites have their weights adjusted because once they're compared to other series, um, they might be slightly off, so they always can be slightly tweaked, and they're always compared to the reconstructed T average. Now, sites that significantly deviate from the local group have their weights reduced as well, and this is just following a trend that is it's reliable or at least expected. Um, Therefore, the influence of such sites don't fully change the expected graph and what things pretty much should be for the most part. And then even when the sites have great warming or are part of the data set being used, they're still reduced just to stay in correlation with the rest of the data. So all this data has been gathered from the 1850s to early modern day 2010, 2013, and there's a comparison of the temperature estimate for all the land sites. And this is, of course, after all the reductions have been made and all similar tweaks, as you could say. Now, the standard errors are calculated by adding the statistical uncertainties calculated for each average using the jackknife method. The jackknife method is a method that basically trims away any erroneous data, which is to say that the use of modern stations um, is used in stations that were used several years ago, which weren't as reliable as the modern technology. So it's to say that with the technology being used now, you would have more accurate data. Now, the data shows the difference between the land sites and the rural land sites is consistent with zero within two standard levels. From 1950 to 2010, the climate is considered more acute. The temperature difference had a slope of negative 0.10 plus minus 0.24 degrees Celsius per century. And also the difference in the trend curves was slightly similar over the 100 years, for the century that this data was gathered. But this is all still to consider. More importantly, that when some data is significantly overwhelming to its group, it's always reduced and it's always trimmed down to have a better, best fit line.
So to recap this presentation, the basis of the paper that we reported on was trying to show the result of a study trying to determine if the UHI effect or urban heating island effect actually occurs in our global environment. It's believed to be the result of the physical differences between the urban and rural environments that we observe. This could be due to the varied absorption of sunlight, the heat storage in the man-made structures, differing air circulation, or the lack of plant transpiration. Differing opinions in prior studies showed that the GISS, NOAA, and the HAD-CRU found minuscule corrections were needed, if any, were required to conform their data to any UHI effects, while the Delat and Marialis and McKittrick and Michaels found significant trends related to UHI. The data that was collected was broken down into very rural and not very rural data sets. They used monthly data from approximately 37,000 stations, where approximately 16,000 stations classified as very rural. You can see there's a miscorrelation because that 5% of the Earth's landmass is considered urban, which would fall under to the not very rural, but a vast majority of the stations fall under the urban classification. The authors of this paper used a simple straight line fit to formulate the trends. They encountered some data bias where some of the data had gaps, or the data was of a short term where the data trends or the temperature trends seemed to increase more rapidly. But once they accounted for all these biases, they were able to confirm that the warming trends for the very rural group was actually larger than the all group, which is contradictory to the UHI effect, where all sites experienced a 0.96 degrees Celsius increase per 100 years, where the very rural sites increased by 1.1 degrees Celsius per 100 years. In conclusion, there's little evidence that the UHI effect affects temperatures globally. If assumed that UHI affects the temperature, then the effect is minor, and if not almost insignificant. The lack of effect attributed to these urban areas can be contributed to that urban areas are only 5% of the Earth's landmass. This report only looked to account the land area. If oceanic data had been used, then the effect of UHI would have appeared to be less. The authors of this report are looking at including oceanic data to incorporate in a future report. If you have any questions regarding the topic of this paper, feel free to contact any of us that worked on this report, and we would be happy to enlighten you on any of the questions that you have.